Greetings, the Astro 30 here, and I've got another kit here to build, which should be fairly interesting. Now, it's fairly late at night, it's about 11 PM. I just finished work not long ago, and of course I'm consuming alcohol, as you do. Now, I'm not advocating drinking or anything, but yeah. Now, this kit is actually a stereo preamplifier with bass, treble and mid-range controls. They call it alto, but it's the same thing. It comes from China, and the instruction manual is in Chinese. Of course it would be. There's nothing really relevant anyway with this. It's just basically explaining what the controls are, what they do, etc. There is one issue with this particular kit. So if we take the circuit board out of the bag of components here, and if we look at where the volume control is, which is this one over here, you'll notice it's marked B50K, which is a linear dual gang pot. Now, okay, you may be saying to yourself, this is fine, but no, it's the way they have actually configured the pot, the way they've wired it and routed it on the board. And of course, this contains no schematic to it, so yes, I reverse engineered it. Okay, here's the reverse engineered schematic. Please excuse the crudity of this drawing. I didn't have time to do it to scale or even to paint it. Yeah, that's getting old. Okay, anyway, basically the setup is here. They've got an inverting amplifier stage here, and the calculation of gain here is R2 divided by R1, but it's minus. So we're running around about a gain of 4.5. We'll say, but it's minus 4.5. We won't get into the details behind inverting and non-inverting op amps. Just remember that there's going to be a 180 degrees phase shift on the output compared to the input. And the way they have chosen this as an inverting amplifier is probably a good idea, because over here we have what is known as an active Baxandal tone control network, and that's also an inverting amplifier, and this inherently will phase shift the output 180 degrees. So if the input to this is already 180 degrees out of phase, what's going to happen? Well, the output is now going to be in phase. So just talking about the volume control, the way they configured it, it's the standard configuration. You have an input here on the 3rd pin, which is the clockwise position. It's grounded on pin 1, the counterclockwise position, and the output's formed at the wiper. Now remember, a volume control, a linear pot does not make. Our hearing is logarithmic, so there's going to be a sudden jump in volume when you rotate it no more than an eighth of a turn, because it's the way our ears perceive loudness, which is why we use logarithmic pots. So in the kit, it's wrong. It has to be a logarithmic pot, just like that other STK 4191 amplifier I built has to be a logarithmic pot, and they use these type of pots. So I went out to J-Car and just bought a 50K A, or logarithmic pot. You can always remember the difference between these pots. The A you can mean to stand for analog, log, and B is linear. Also, please forgive the amount of shadowing going on here. I've got a light directly over to my left, really close to the desk, because as I said, it's pretty dark at the moment. It might have something to do with the fact that it's night time. Maybe, I don't know. And back to the schematic, I've only just drawn the left hand channel. The right hand channel is exactly the same. Hence I've used R101, R102, C101, etc. notation, so that on the right hand channel you just transpose that to 201 202, etc. And yes, this kit actually does come with NE5532s, believe it or not. So I'm happy to see that. And down the bottom we have an onboard regulated power supply made up of a 7812 and a 7912, positive and negative regulator. Conversely, please ignore this dot join mark between the ground, the anode of the LED and R1 here. That's supposed to be straight through, not connected at that point. I made a slight error when I was drawing the line through. I just went boom, 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 and didn't really check what I was doing. Hence I've got a circle around it. I have made this schematic available in the description for you to look at as a JPEG image, and this has been corrected. So I'm not going to talk too much about the schematic. It's pretty simple. It's as simple as a preamplifier comes. Yeah, our expected output voltage peak to peak with a 1 volt voltage in is around 4.5 volts peak to peak. So we can expect to see that. That is if the mathematics is correct and, you know, tolerances of the circuit. So anyway, I think it's time to plug in a soldering iron and get building. This is a fairly crappy sponge that came with this soldering iron stand. I mean, look at how it's going brown because it's burning a bit. Oh well, might have to come up with a better idea than that. Like a better sponge. This thing just sort of like floats around in the breeze and it's kind of annoying. Anyway, this board is quite nice. It's double-sided, plated through holes. Very nice. I'm going to first start with the resistors as normal. I believe these come with IC sockets, although they may not. No, they do come with IC sockets. So I'll do all the resistors first, then the IC sockets, and then maybe I will do the diode bridge, maybe the input and output connectors, the capacitors, and then yeah, we'll go from there. And this is what I love to see in a kit, when they actually supply the resistors with similar value in these strips. So at least it keeps them all together so you're not searching through where's the next one. So that's always nice to see. I wish all kits were like that, but they're not. Because of the lighting in here, I'm not even going to attempt to try and read half of these. I'm just going to stick them on a multimeter and find out what they are and put them where they go. Okay, I've started by putting the 18K resistors in, and I'm putting all of them in bar once, only 4. The reason for that is because the other 18K goes over here, which is R1, through to the light emitting diode. Now I'm not going to be putting either of those components on this board, and there is a specific reason for that. Well, there's two. One, I don't need it, and the second one will become evident a little bit later in another video. Okay, that's all the resistors installed, so I think I might move on to the 2 IC sockets for the NE5532s. Okay, I've got the 2 larger MKTs in, the 3 terminal screw header things, and also I decided to put in these 2 little headers as well. I thought, well, they're there, might as well. And that is the soldering complete. The kit is assembled. All I've got to do now is just straighten the pins on these NE5532s and pop them in their new home. I love those matched pin IC sockets. They're awesome. They were used in old 70s computers. They were great. Again, I'm going to have to buy myself an IC inserter tool. There we go. That's both the op amps installed. Now I can do some testing. or just sit here for about 20 minutes basking in my glory. Feel the power. Now, how long did that take to build? Well, I started probably around about 11:15 at night. It's now 12:15, so I would say an hour. So the average constructor should be able to construct this within 1 hour or to an hour. It's pretty basic. So yeah, anyway, next is some testing, but I'm going to have a little bit of a break and have a smoke and have a Kit Kat and yeah, all that fancy jazz. Oh, wow. Okay, before I get into any testing, Jesus, I'm just going to, I don't know how well this is going to work, probably not going to work at all. Okay, so I'll go to, I was going to mount these on standoffs so at least it wasn't scratching the shit out of the desk, but I only have 3 10mm ones. I need to buy more. I thought I had 4 of them. Apparently not. Okay, so for now, what I'm going to do instead is, well, I could do it the other way, I suppose. I could use this. I've only got 3 of these 15mm ones, which actually screw into these, so I'm missing 1 somewhere. I don't know where it's gone, what I've used it for. So instead, what I might do is I might just put a screw through here, which will probably work better, and just screw it on there. Yes, the thread's going to stick onto the desk, but it's going to scratch it less than the solder joints are. There. That's a bit better. So that's what my plan was anyway. Now, moving on to testing. Okay, I've got everything set up. I'm just going to turn on the DDS. Make a liar of me. I actually set this shot up because sometimes when I turn this power on, I just get blocks across the screen like the LCD fails to initialize. This time it seemed to work fine. Okay, so I'm going to preset this to 1 volt. That didn't work. 1 volt. There we go. Whoops, knocked the DSO over. Got the power supply set to around about 21.3 volt. That's going into where the AC normally goes in. That's plus minus 21. I'm currently at 10 volt per division. 5 volt per division should be enough. So I'm ready to turn it on and see if we have an output on the scope. Well, we won't until we increase the volume control. And we do, but it seems to be clipping badly. That is the most horrible, horrid looking thing I've ever seen. Chips are not getting hot. Because if you increase the treble, the signal disappears altogether. This is not right. Nowhere near right. I don't know why it's doing that. It's like it's not getting a negative, well, a positive output. So unless I've got a dead regulator IC. So okay, if it fails to do what it's supposed to do, thou shalt measure voltages. So I'm just going to measure the voltage across pin 8 and 4 of each IC and make sure that it's close to 24 volt. Yes, 24 volt on that one. Yeah, it's 24 volt there, so that's kind of strange. So that's a good indication to me that it's not working properly. So that's on the left channel, so I'm going to switch channels around and measure the output of the other channel and just see what we've got here. The same. So yeah, something's not working right. Yeah, that's rather annoying. Okay, so interestingly, what I've gone and done is I have put the input directly into the back-handle circuit. That is, I'm coming on the other side of this 1K resistor here, totally taking U1 out of the equation. I am getting a decent signal. The thing is, when you rotate the treble full, well, yeah, that's what you get. So I am seeing a decent signal, and these controls are actually doing something. But I did measure the output directly off of U1, and yeah, it looks like absolute crap. It's still missing the positive half of the waveform. Yeah, this is just absolute crap. I don't know offhand what's going on here, and I've just gotten to the stage where it's late at night. I don't really particularly care now. It's like 1 in the morning now, and I'm not getting anywhere. I've tried different ICs, op-amp ICs, and it doesn't seem to make much difference. So because we're missing the positive going cycle, it's not going to sound very good. I'm currently very disappointed in this amplifier or preamplifier. It's just not working as it should. And well, I'm not exactly sure why. It should be, but the results I'm getting is not what it's supposed to be. So this is another failed project. I'm very disappointed. Okay, it's the next day and I've slept on it a bit, and yeah, thing is, we have a good sine wave coming out of the back-handle circuit if we apply the input to it. Basically taking this first op-amp out of the equation. Also, if we remove this IC whilst it's running, because of the way the input resistor network and feedback network is configured there, with the IC in, we're losing the positive half going cycle of the waveform. As soon as we remove it, a nice sine wave comes back again, which leads me to believe that we have a bad solder joint. Like something is not being earthed correctly around the IC, or the resistor's not soldered properly. And I did examine this last night, and I did notice a few of these resistors, the solder hasn't come all the way through the through hole correctly, because I was having a bugger of a job soldering with that T12 soldering iron to the ground plane on this. It was taking a lot of heat. So this is where it's leading me to believe that maybe I have a bad solder joint. Now, it made no difference if I swapped the ICs around, same results, or even changed the op-amp ICs to something else. I tried a UPC, micro PC, sorry, 4558 IC, both of them, which I borrowed out of the other kit, and I got the same results. So it's indicative now that there is something wrong with this input preamp, because we're not getting a very good output sine wave. We're getting one half of the waveform chopped off. and it's very low in voltage. I'm getting about 1.8 volt peak, well, peak anyway, and we're missing the other peak. So it's basically like this IC might as well not even be in circuit. You pull it out and it functions fine. Also through testing, I mistook this for the bass pot. That's the treble pot, mid-range bass. It's backwards. That's beside the point. I went out and bought some knobs for it, so well, mainly to give it a more positive feel here. Now, back to my issue. Yeah, I believe it's solder joints, so I'm going to reflow all the solder joints around it and see if that improves the situation, because we should be having at least 4.5 volts out of this thing, peak to peak, and we're getting nowhere near that. It's not even working as a preamp. So that's my next course of action, is to reflow the solder joints, but I'm going to use my Duratec soldering iron for that because it has way more heat. So that's going to be my plan of attack. So I'm going to reflow the solder joints now, and I'm going to hook it all back up to a power supply and yeah, go through the testing again. That T12 soldering iron just simply does not have enough heat. And that's the most annoying part about it. So I'm just going to touch up some of these joints. Okay, I've reflowed basically every single solder joint on this thing, so if that doesn't fix it, nothing will. Okay, time for testing. And also, I went and bought some more of these test jumper leads because I'm sick of not having enough. So yeah, that was only like 11 bucks, 12 bucks. Okay, got everything set up here. Power supply's at 21.6 volt, plus minus. That's fine. It's currently, the load is off. Actually no, the load is on. I'll turn the load off for now. Okay, turn that. This is what I mean. That's what the display on the front of that is doing. Sometimes when you turn it on, it's just like it's not being initialized properly. The LCD is not being initialized properly. Turn it off and back on again, and it works. So I just want to find out what we're set to. 6 kilohertz. Another thing I noticed about this is if you change the frequency or the amplitude, say I want to put 1000 hertz, well, it changed that time, but sometimes it doesn't change. Anyway, fingers crossed that this is working properly now. So I'll turn the load on. The volume control on the module is down. So nah, I don't really have time for this crap, so I'm going to change that. See, as I said, we get a proper sine wave at the input of the back handle, but at the input of the preamp, it just goes to shit. So I don't know what's going on here, so I'm going to remove this op amp, and if I turn the amplitude up, you can see my normal sine wave returns, as I previously stated. So I'll stick one of these TL072 op amp ICs in its place. It is possible that the IC could be damaged as to why it's not functioning. And we've got exactly the same shit. Although, that's interesting. If I put my finger across it and push on the IC a bit, yeah, sine wave is coming back. Well, what do you know? Would you look at that? If I increase the voltage to 15 volt, look at that, we've got a nice perfect sine wave now. What I've done is I've run a wire off of pin 3 of the positive regulator and another wire off of the pin 3 of the negative regulator and hooked it directly up to the power supply, which is now running at plus minus 15.1 volt. So now we actually have the correct output that we should. And we're doing a V peak of 4.7 volt. So yeah, pretty close to 4.5. So that's only at the output of the first IC, which I can now plug in properly. Just lost my signal. Yeah, so that means that the plus minus 12 volt rail is not enough for the ICs to function correctly. 15 volts would be where it is, so that means I'm going to have to change these two regulators eventually, which are now getting quite hot, but that's because I'm putting voltage into them. So what I'm going to do is I'm going to take them off the board. Okay, it was a considerable amount of effort to desolder them. I actually ended up cutting them off, and yeah, they're not that expensive anyway, and cleaned out the holes, and now I've got it wired directly across the positive and negative rails. We now have at our output, going through both ICs now, a voltage peak to peak of 3.24 volt, slightly clipping at 15 volt. So if I just increase it just slightly, we get no clipping. So it probably would be that a 1 volt input is probably slightly optimistic. So I'm going to set it back to 900, and the clipping goes. So the ultimate question is, well, let's hook it up to a power amplifier and see what it actually does. Okay, got it hooked up. I can hear the bass is working. Mid range is working. And radio signals. Treble's working. So I know that the tone controls work, and all I need to do now is feed in an audio signal. Okay, got it hooked up to my computer. Now let's have a listen. Sounds like it's clipping a bit. Find a different track that sounds like shit. Oops. Sounds alright actually. seem to be too much gain there though. Bass. No bass. Mid-range. No mid-range. Full treble. No treble. No mid-range. No bass. It sounds like a porno track. That has got to be the most annoying track that I have ever heard. So it is working, just not with the 12 volt regulators that they supply. It won't work correctly and it would sound distorted because it's missing one half of the waveform. Well, it would sound like it was experiencing major crossover distortion. It would be clicking and popping and whatnot. And you wouldn't have much gain. So you're going to have to go and buy, if you use one of these kits, you're going to have to go and buy a 7.815 and a 7.915 respectively to change those 12 volt regulators. Other than that, it works fine, and as long as you keep the AC input voltage at 18.018, it should work fine with the 15 volt regulators there. Anyway, thanks for watching. I'm the Astro 30, and as always, if you like this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyways, this is the Astro 30 saying, see ya, have a great day, and I'm not your Darlington.